Today we're going to talk about variables and primitive data types, and if you're new to programming, then I just threw a whole bunch of programmer jargon at you. But that's okay, because you are going to learn what those things mean. Now, if you're not familiar with variables, you can think of a variable as a box of memory that you can store stuff in. It's just like a physical box in our world. We can put something in there, and then anytime we wanted to retrieve that box's contents, we could do that. But the only difference within programming is that that value that we put inside of that box stays in that box. So we can retrieve what is contained within that variable, but whatever was in there is still there until we explicitly get rid of it. So this means that with a variable, we can assign a particular type of value to a variable, and then we can reuse that variable over and over and over again wherever we need to. And 99.9999999% of the time, your applications that you write are going to be using variables. It's just something that every programming language has, and it is an integral part of a programming language. But not all languages handle variables in the same way. We can divide languages into two categories. One category is static languages, which C# is a static language. And the other category is dynamic languages. Languages like JavaScript or PHP or Ruby or Python. Those are dynamic languages. In dynamic languages, we can create a variable and we can put anything inside of that variable. So we could put a number inside of a variable, and then later on, if we decided we want a string to be in that variable, we could do that. And that's perfectly valid. That's how those languages were designed. Static languages like C# are completely different. We can create a variable, but we can only store a certain type of data in a variable. And we have to declare what type of value we want a variable to be whenever we create that variable. So whenever we create, say, an integer variable, which is a whole number, we can only assign integers to that variable. We cannot assign a string to it. And that's just an aspect of static languages. Some people don't like that. I happen to like both static and dynamic languages. So it doesn't bother me, but it does bother some people. Let's create an integer variable and give it some type of integer value. Let's give it a value of 10. So in order to create a variable in C#, we have to first specify what type of variable we want to create. Now, an integer is specified by just typing int. It's short for integer. And int is a keyword. And a keyword is just a special word that is used by the C# compiler in this case. Whenever the compiler sees int, it knows that we are going to do something with an integer. So we have specified what type of variable we want. Now we need to name our variable. And we can name it by an uppercase or lowercase letter. Well, it can start with an uppercase or lowercase letter, or it can start with an underscore. But typically, if you are creating a variable, it's going to begin with a lowercase letter. And we'll talk about naming and all that wonderful stuff later on whenever we start talking about classes. But for now, I'm just going to call this variable foo. And this isn't something that I've made up. If you read a lot of programming literature, basically, you will see foo and the other word bar used quite frequently. It's just kind of a throwaway name that doesn't really mean anything, but whenever we need a name for a variable or something else, then, foo or bar is really handy. So we have specified what type of variable we want with int, and then we have a name for our variable foo. And now we need to give it a value. And we do that by using the equal sign and then the actual value that we want to assign to the variable. The technical term for what we have just done is defining a variable. We have declared it by saying what type it is and given it a name, and then we have initialized it with a value. Now we could do these two things with two separate statements. This is more common, how it is right now, defining the variable. But sometimes we need to declare a variable first because we don't know what value to give it at the time that we declare it. So we can declare our variable by using the data type, int in our case, and then the name of the variable, foo, and then we can what's called initialize it with a value later on. So we can assign 10 to it. This is common as well, but it's more common to define the variable by all in one statement. Just to demonstrate the rigidity of static languages, let's change this number of 10 to a string. And remember from yesterday's lesson, we begin strings with a double quote, and then we end it with a double quote. And we can see that we have a red squiggly line. Even though it's a string that has the text 10, it is still a string, and we cannot assign a string to an integer. And the red squiggly line means that that is an error. And if we tried to compile our code, the compiler would not compile. It would come back and say there's an error on line 12. If we move our mouse over this red squiggly, we can see that the error is that we cannot convert a string to an integer. So just keep that in mind, and at least Visual Studio will catch that for you. So if you make a mistake, which everybody makes mistakes, then Visual Studio is going to catch that for you, which is really nice. So let's create another variable. I'm going to call it bar. It's going to be an integer as well, and it's going to contain 10 as well. Now we have two statements here, one for the foo variable and one for the bar variable, but we can compress this all into one statement, and we do that by using a comma. And then we get rid of the int before bar, and then that's that. So we have int foo equals 10, bar equals 10. And anything else that we wanted to declare as an integer, we could do that here. So if I wanted to create another integer variable called hello, and we could assign it a value of, let's do something like foo. Now notice we didn't use a number literal, and a literal is something that literally appears within the code. Here we have used the literal number of 10 to assign to the value, or to assign to the variable of foo and bar. But for hello, we have assigned the value of foo, which is 10. And we could do the same thing for bar. Let's do world equals bar. And so this is where the power of variables come into play, because not only can we store values into those variables, but we can reuse those values anywhere we need to. So let's just change this to 12. So this means that hello is going to contain the value of 10, and world is going to contain the value of 12. And so that's just how you can assign a value to a variable and then use that variable as the value that is assigned to it. All right, enough about integers. Let's talk about some of the other primitive data types. And when I say the phrase primitive data type, I'm referring to the most basic types of data that a language provides. And they are typically built into the language just because they are primitive data types. All the other data types are built upon these primitive data types. And we will actually build some more complex data types whenever we start talking about classes and things like that. So integer is a primitive data type, but we also have other types of numbers. An integer is a whole number. It can be negative, positive, or 0. But sometimes we need a little bit more precision than what an integer can give us, and that's where the decimal place comes into play. And we have multiple decimal placed types of numbers. The first one is a floating point number. I'm going to call that foo. And 3.14. Now, there's a problem here because we have so many different types of decimaled numbers. We have to specify what type of number it is. By default, everything actually goes as a double floating point number, which is a floating point number that has a greater breadth of precision. So if we change this to double, which is also a primitive data type, then the red squiggly goes away. But let's change this back to float. The red squiggly is here, so we have to say that this number is a floating point, so we put an F at the end, and then the red squiggly goes away. Now, the problem with floating point numbers is that they are not accurate, and it's not a problem necessarily with C#, it's just a problem with floating point numbers in general. Any programming language that has a floating point number data type has issues, and it's just because they all implemented the floating point data type based upon the floating type standard. So if you do some arithmetic with decimal places, you might not get the results that you are actually expecting. Like, for example, if you took 2.5 plus 2.5, you might not get 5. You might get 4.99 or 5.01 or something. I don't really know what you'll get, but there are some cases where you will not get the actual result that you were expecting. In cases like that, and by the way, that's for float, that's also for double, because double is just a larger floating point. For accuracy, for things that you need absolute accuracy with a decimal number, you can use the decimal data type. This too is a primitive data type, and you use the character M at the end of the number to specify that this is a decimal data type. And decimals are extremely accurate. You can use them for currency. You would not want to use a floating point number for currency because they aren't accurate, but decimals are accurate. And this is why many other languages have other types of decimal numbers, like C# does. C# has a floating point, a double floating point, and a decimal. And it's because floating points aren't accurate. So C#, Java, I believe C++, most of these languages have a true decimal data type that is 100% accurate, so that you can work with currency and things like that. So those are the majority of the numbers. Let's look at characters. A character has a keyword of char, and a character is just a single character. It is not a string. If we try to assign a string to a character, we are going to get an error, because a string is not a character, and a character is not a string. So to specify a character, we use the single quote instead of the double quote, and the red squiggly goes away. And a character is only one character. We cannot put two characters inside of a character literal. We get an error and it says too many characters in a character literal. So a character is only one character. And a string is a string of characters, and we'll talk about strings later on. A string is not a primitive data type. Okay, so we've covered integers, floating points, decimals, characters. We need booleans, because booleans are very important. It's actually spelled boolean like that, but the keyword is bool, foo, and this is a true or false value. So it can be true or it can be false. A boolean is a lot like a bit. In the computer system, a bit has two states. It can be either on or off. So a boolean, a true would be on and a false would be off. So that is the boolean value. And I think that is it. Well, there are actually other primitive data types, but for the sake of simplicity, I think I'm just going to leave it at that, because there are things like bytes. There's also different types of integers that we can look at. So just to keep things a little bit simple, we're just going to stick with those primitive data types. In tomorrow's lesson, we are going to focus more on the numbered data types, the integers, the floating points, and the decimals, and we are going to look at some of the arithmetic operators, because math is something that we have to do in our programs.